Alright guys, welcome back. I'll be continuing our learning journey in building our simple shell using C programming. Now in the previous video we've talked about processes, we've talked about types of processes, the init process, daemon, zombie, orphan, and then your user defined process, and then we've talked about the concept of ripping. We also talked about arguments to running program, arguments to main, using void, getting string input with functions, and also knowing how to split a string. That's string splitting. That's that about phase 1. Now for phase 2, we are actually going to be diving in deeper into key concepts here, and I would actually like us to pay close attention. Okay, all right. Now I also do understand that for a lot of us, we kind of having difficulties in actually understanding C programming and some other projects. So there's gonna be a kind of boot camp on C where we're going over all taxes, and then I'll take you by hand in explaining some hidden things that we might not have understood while we're learning them, or more stuff in which we also need to actually add to our knowledge. Okay, that's by the way. So let's quickly get into the video. Now in today's video rather, we'll be talking about system calls and library calls. I'll quickly also talk about fork, orphan, zombie, and then we'll actually write a program to kind of explain this. Now when we talk about system call, what are system calls? Now when you say something is a system call, it means you are like making a request to your kernel. By kernel, I'm like saying you are making a request to your operating system that you want to use a resource in which it is managing. It's just like, let's say, a system call can be likened to a stranger coming into a building that has a gate man. Now for you to enter inside that building, probably to collect something, probably to do one or two activities, you will need to seek permission from the gate man, right? Exactly. So it can be likened to that aspect. Now a system call is you making a request to your kernel, to the system kernel. It might be your Windows or your Linux kernel, that you want to use a particular resource, a particular hardware resource. Now a library call is you actually using a library. Now you are no longer using, is not a call to your system, it's a call to a particular library, or it's a call, you can liken it to be you placing a call to probably your friend that, hey, you actually wrote a code to do something, what's the code again? And the person answers you that, okay, this is the code, and then you just use it. Yeah, I'm kind of making a library call that way. So that's what I want to kind of differentiate there. When you're making a system call, it is a call to your operating system. It is concerned with your operating system. While when you're making a library call, it is your operating system is none of its business. Just like when you're kind of for Python, you're importing a module, or for C, you're including a header library, and then inside that header library you're kind of making a call to a function. Now okay, let me quickly use this as an example. Okay, let's see, let me do vi. Okay, now you could see here I have in my printf statement, which is actually declared here. Now I'm in here, I'm actually making a library call. I'm making a library call to this stdio what library, because I'm using a function inside that library. Now the function inside that library is what? The printf function. Now when you make this particular call, let's say you are making a write call or an open call, now that's no longer a library call. Now it's now for your system itself to actually open a file or to write to a file. I hope we actually understand that. Okay, so I'm just going to quickly exit this. That's for our system and library calls. Now when we actually start up our machine, we have actually understood the fact that we actually initiated a process. Now I would like to bring to our knowledge, in case you didn't watch the previous video, I will advise you to actually go back and watch them. Now a process is an instance of a program, or a process is a running program, or a program that is what? Executing. Now we've also said from the previous class that all program has its what? Unique process ID. Why does it attach this unique process ID? To not conflict them. Like right here now, I have two terminals running here, and if I'm going to come in here, I'm just going to do this here also. I'm coming here to do this. Now we're going to see something very, very unique. Though it's same virtual machine I am logged in, but now you could see that the process ID that it returned is different. Here is 996 and here is what? 121712. It's totally different, meaning now this particular guy here, which is 996, is independent of this, because they are what? Of different process ID. Okay, all right. Now when we now run a program, now just like the way I kind of did, or let me run this executable here, which is A. Okay, now when I did this to execute this particular command, a process was actually created, and then this program was loaded into that process for it to what? Execute. Now if we look closely here, you see that this my current process here is what? 1712, which is what the parent process. Now when I actually typed in this and I pressed on enter, a new process was created by process 1712. And when it's process 1712 created that process, the process ID was 1715. And on process ID 1715, the program that was running on it was this. I hope we actually understand the way I actually broke it down. Now what just happened is what they call what? Forking. Now forking is the process whereby a running program creates another process of its own. I could say whereby a running program creates a child program, or you could say whereby a running process creates a child process. Now the child process is called what? Forking. That's what actually happens here. So 1712 was able to create 1715 by forking it. Now when it forked it out, it actually was created 1715. Okay, so I think I'll come in here, right here, come in on this terminal, and then just do man fork. So we just use okay. Now fork means what? To create what? A child process. Meaning here it's actually comes to actually re-emphasize that what I actually said here was actually correct, because 1712 it's a running program. You can see it's running, it's waiting for me to enter a command. It's still running. Now when I passed in the command, it created another process to actually run that command, which was 1715. I could run it again, and you can see now it's 1773. Okay, now one thing I also like us to actually understand is that when a process is being forked, it has the same commands. It is actually saying the same commands that the parent process is actually what? Executing. Now I'm going to demonstrate this. So let me just say fork.c. First I'm just going to include my stdio.h. Okay, now for me to actually using the fork system call, I need to include these two header library, which is the systypes.h and the unit.td.h. So I'm just quickly going to do that. I should include systypes.h, then okay, now I'm just going to write a simple doc string here. Okay, sorry, here ought to be main. Okay, so that's that. So there's the int main. Just going to say void here. So I'm just going to return 0. Okay, cool. Now, like I said that earlier, that when a program creates another program, creates another process, like a child process, it's both processes actually what? Seeing the same commands, meaning the stack is still the same. It's like an identical from the point of where that process was actually what? Forked. Now I'm just going to prove that. Let's just say I'm going to say int age should be let's say 40. Okay, so for here I'm just going to come in here and do period underscore t should be come in here. Let's say this should be my fk period. Oh no, let's say this should be my child process id. Okay, so now from here I'm I'm just going to call my fork. Okay, now let me quickly explain this. Now fork doesn't take in any arguments, but it actually returns a value. Now what does it return? It actually returns the process ID of the child process to the parent process. That's just basically what it does. Now I can come in here now, then to come in here, let me just give space printf. So I want to print in the value of a, which is use %d for that. Going to print a. Now I want us to actually watch this closely. I want us to actually watch this closely. Then I'm going to come in here. I'm just going to put in another printf statement. Okay, so let me just say done printing. Okay, would I like to see anything else again? No. Okay, so I'm just going to come in here, then going to use just GCC this, then let this be FK. Okay, so I can run. Or before that, I think we should actually see. I think it is actually necessary for us to actually see the process ID. I think it's actually necessary. So let's say I want to then print. Okay, I could come in here and then says, instead of I'm done all, call another printf statement. Then I could come in here and say parents speed, which is the distance of parent process ID. Then just put this and say child speed. So I'm just going to use the get pped for my parents, then get speed for my child. Oh, I didn't close this. Alright, cool. Okay, alright, now yep, that's cool. Let's come in here. Okay, sorry, used in the wrong. Okay, I used in the wrong format specifier. Let's come here, change it to D. I can actually still use %u though, but I'm just going to leave that way. Okay, so let me just quickly do a review here. I'm creating an integer variable a. Yeah, I'm actually creating a variable called child process ID because I know that my fork function is actually going to create a process, and then it's going to return a process ID to the parent process. So the parent process is actually going to hold the process ID of the child. Okay, all right. Now in the child also, now because remember I said that immediately if the fork system call or the fork function is called, two process is now running, and those two processes actually seeing what the same command. So in my fork function, in my forked process, which is my child process, this child process ID is going to be reading 0. Okay, I think let me just compile this now. Here should be I'm done. Compile this, then okay. So let me do gcc fork.c. Oops, I actually made it an a.out file. Alright, so no problem. A.out. Okay, good. Now parent speed is what 1712, which is actually what the original process ID. If I'm going to come in here and do this, now this is it. Parent process ID was 1712. Now look here, guys. Now look here, I have what a child process ID, which is what 1825. Now on my parent process, now this guy here is the parent of when I called in a.out. So 1712 actually forked out 1825. Now on this 1825 is where this a.out. So let me just do my cat fork.c. Yes, so we could actually just have them on the terminal here, so I can just explain clearly. Now when 1712 was actually this my current program here, this is my current prompt. Now when I did my a.out and I pressed in enter, 1712 from this line actually created 1825 to actually run my ./a.out, right? So when a.out was running, when it got to this point, it saw parent PID get pp'd, so it actually came in here and brought out the parent, like the process that actually gave birth to it. Now what process actually gave birth to it? It was what 1712, but what is its current process ID? 1812. And then it said what it is, what done printing. I'm done printing, right? Now you can see the reason why it's not going to a new line here, because I didn't put in my \n. I didn't put in my \n here. Sorry, you can see, sorry, this is where, let me not mix this up. This is where I am here. You can see I didn't put in my \n. There you see I'm done printing. So now this is the parent process, right? But now something tricky has happened. Now I created a fork process, right? So on this point now, from this point downward, I now have two processes. Now we've actually analyzed the first process, right? Now let's talk about the second process. So please, I would like us to actually pay close attention. Now on the second process, which was actually the forked process, that means which was the process in which this guy here, in which 1825 actually created from this fork process, because 1825 is the process starting from here to this point. But when it gets here, 1825 then created what 1826, right? But now something funny actually happened. Now 1826, instead of it to return 1825 as its parent, right, it is actually returning 1, right? It's actually returning 1, and then it actually still sees what I'm done printing, right? And if you actually pay close attention, you will notice I actually had to press what my enter key to actually bring back my prompt. Okay, So let me make this much more elaborate, because now in this particular video I'll try to not even I'll try I'm now bringing the concept of what the fork system call and the orphan in this video. So that's what I want to quickly explain here. Then in the next video I'll talk about the zombie and then exec-v. Okay, so quickly come in here. Okay, and in this here I'm putting the \n first. Then I'm going to, before this I want to print something. So you see that there was actually a process that was running before. So let's just say I'm single, yeah, and my PID, because we really want to know the PID here, right? And my PID is %d \n. Then I just want to get the PID, right? Because I really want to know, because someone will be like, okay, but Sammy, this is kind of confusing, stuff like that. So I really want to just break it down this way so we could actually just see it. So before it sees this guy here, this line here, we actually want to get the process ID. Now I have actually made those edits. Now coming back here, I think now let me just turn this to FK. Okay, so I have my a.out separate, and then this FK is actually was separate. Let me just clear my terminal to make things beautiful. Okay, yeah, it goes. Okay, good, cool. Now guys, did we see this? I am here, I'm single here, and my PID is 1840, right? Which is cool. Now it's come in here from this particular statement here. You see, we are actually, this line that says printf %de is actually what it is printed here, 40. Cool. Now note, I am single here, my PID is 1840. I think what I should do here now is kind of exit from here. Just going to copy this and then do CD. Then I'm just going to paste. I'm going to paste this and then remove this \. Good. So I just want to do vi fork.c, so we could just have it. Yes, I think this is much more better. Sorry, I'm actually going through this route, but I really want us to understand what is actually happening, because I see a lot of us, we really don't know what is happening. Some blog articles that you will read might even get you more confused, while some YouTube videos also can even get you even lost. So that's why I'm actually taking my time to kind of do justice to this. Now here a single process was running, which is 40. I'm single here, my PID is this. Now which is this? I'm single here and my PID is 1840. Now I'm printing out 40 from this print. Sorry, now I'm printing out 40 from this printf state. Now you notice that this 40 is going, and you notice that this 40 is actually going to be printed twice, because it is actually coming after we've called in our fork process. And this you could see from here and here, it actually printed twice. Now look at this also. I'm single here, my PID is 1840, which is actually the process that 1712 created to actually run this command ./fk. Now when this ./fk was running, it only saw A, which is 40. I'm single here. Now it saw this, a system call to create another process. Now it then created that process. Now when it created that process, when it created that process, I now have two processes now, which is 1840 and the one in which 1840 actually created. Now because I now have two distinct processes, 1840 process 1840 here saw this line here and then interpreted it as, oh, the one that gave it to me is what, 1712, but my own process ID is what, 1814. I'm done printing, and it's done. Now the child comes in and it actually was seizing A, and actually comes in again and still prints what, A, because I said earlier that it's the same thing that is actually duplicated. So it actually comes in here and sees the same variable and then prints it, which was 14. But now what happens? Now it comes in here and see what, parent paid, child paid. Cool, right? Now parent paid, it ought to return 1840, but why didn't it return 1840? Now this is the reason why it didn't return 1840, because 1840 was already done executing, and as such 1840 is no longer in the process table. So 1712 actually what ripped out 1840, because it was 1712 that actually created it, right? Now 1841 automatically becomes an orphan process. Remember what we said about orphan process and what, zombie process. Now 1841 became an orphan process. Now because every process needs to be ripped by its parents, now 1840 has already been ripped by what, 1712. Automatically the init process, which is actually giving the process ID of 1, which is actually the mother of all processes, immediately adopts 1841. Now when it adopts, it was at this point init adopted that 1841. Now when init adopted 1841 now sees what, init process as its what, father. That's why it was actually returned what, 1, and then came back to print its own process ID, and then says I'm done printing. And then you could notice here that there was a prompt here. This particular that was blinking here was just here. Then I had to press in my enter for it to come back to this, whole guy here. I hope we actually understand it now. Now when you actually using the fork system call, it actually what creates a duplicate of the current process and loads it up into that new process. Okay, cool. I think we'll have to stop here now, right, for fork and orphan. Now in the next video we'll talk about zombie and then exec v. All right, thank you all for watching. Do subscribe, give the video a like, and also share to our friends so we could actually kind of understand this little thing, so we could actually go in there ourselves and build our show. All right, if you are actually interested in our bootcamp, C bootcamp, you could actually drop in a comment below, and then I will actually add it to the program. All right, have fun, guys.